Almost every hydronic system I've seen in my career uses an outdoor air reset control. But how do they work? Welcome, friends, to Boiler Room Detective Channel. I'm your host, Ray Wolforth. Let's start with the design of the heating system. When sizing the boiler for a hydronic system, we have to ensure it will heat the building or home on the coldest days. The designer will use the published design temperature for the area. In my area, Pittsburgh, Pennsylvania, that temperature is 5 degrees Fahrenheit. This is referred to as the 97.5% temperature. For 97.5% of the heating season, or almost 98% of it, the outdoor temperature will be at or above 5 degrees Fahrenheit, which leaves 2.5% of the winter will be below the design temperature in the area. Pittsburgh has an average of 4,000 heating hours per year. Using these numbers, we see that a boiler designed for 97.5% of the time, or 3,900 hours a year, we will have 100 hours where the temperature is below 5 degrees Fahrenheit. During those temperatures, the building may not be able to maintain 72 degrees. It may drop to 68 or 70 degrees. Usually those temperature extremes occur at night when people are sleeping. Another part of the heating system design is the design water temperature. Most hydronic systems were designed for 180 degrees Fahrenheit water temperature. The system will heat the building at the outdoor design temperature of 5 degrees using 180 degree water. This also means the heating system is oversized for roughly 95% of the winter. Most hydronic boilers use an outdoor air reset to reduce the effects of oversizing. The system will not need 180 degree water at temperatures above the outdoor design temperature. It may be able to heat the building using a lower water temperature. That's where the reset control comes in. It will lower the water temperature as the outside air temperature rises. The control will have a temperature sensor outside sensing the outside air temperature and one inside sensing the water temperature. The outdoor air sensor should be installed on the northeast side of the building and out of direct sunlight. Using a reset ratio, the control will calculate the proper water temperature based on the outside air temperature. The most common reset ratio is 1:1. That means that the water temperature will decrease 1 degree for every degree rise in the outdoor temperature. For example, in my area, when the outdoor temperature rises to 15 degrees or 10 degrees above the design temperature, the reset control will lower the temperature of the water by 10 degrees or to 170 degrees. On a reset control, the first number is typically the outdoor air temperature. The second number is usually the water temperature. If you set the reset ratio for 1:2, the water temperature will change 2 degrees for every change in the outdoor air temperature. How do you determine your reset ratio? Let's say the heat will operate between 0 degrees and shut off at 60 degrees outside temperature for a 60-degree span. We will reset the water temperature from 180 to 120 degrees Fahrenheit for a 60-degree span on the water. 60 divided by 60 equals 1. Using the same outdoor air span of 60 degrees, we want to limit the water temperature to 140 degrees instead of 120. Operating a non-condensing boiler below 140 degrees could cause flue gas condensation and ruin the boiler, flue pipe, and chimney. When installing or using a reset control on a hydronic system, verify how low of a temperature the boiler can handle. The hydronic temperature span is now 40 degrees. When you go from 180 down to 140, it's 40 degrees. To calculate our reset ratio, we divide the water temperature span by the outdoor temperature span. 40 degrees divided by 60 equals 0.66. For every degree change in the outside air, the water loop temperature will change 0.66 degrees. On a condensing boiler, we might want to reset the water temperature down to 80 degrees Fahrenheit. This will be a span of 100 degrees. 180 minus 80 equals 100. To determine the reset ratio, divide 100 by 60, and that will give us a 1.66 reset ratio. I prefer using the return water for my reset control as it will be more stable. I have seen systems where the boilers will short cycle as the hot water from the boiler causes the sensor to read a higher temperature and shut off. I hope this video helps you better understand how a reset control works. If you found this video helpful, give us a thumbs up and subscribe to our channel for more expert advice and tips. Thanks for watching. My boiler books are available on Amazon, and my technical articles are also included in these industry publications. Thanks for stopping by Boiler Room Detective, and I'll see you on the next case.